Hi friends, welcome back to our channel where we demystify Python coding topics one at a time. Today, we're going to take a deep dive into a special data structure called binary search tree, short as BST, which is a super useful algorithm for efficient searching and sorting. We will walk you through what qualifies as a BST. Then we will jump into some visual explanation along with Python code for its two most basic data operations, insert and search, so you are crystal clear on how BST works. All right, no time to waste, let's get started.
To understand what is a binary search tree, let's understand what is a binary tree. Think of it like this. Imagine a tree, but upside down, with one root at the top, and it has branches or nodes splitting off beneath it. Each of these nodes can only have a maximum of 2 leaves, or child nodes, one on the left and one on the right, which makes it binary. And we call this node above the parent node. We call any node that doesn't have a child a leaf node. Another property of binary search tree is that the left child node is always less than its parent node, and the right child is always greater. This is true for every single node in the tree. With these properties, binary search tree can have many looks. Let's look at an example. We have one root node, 21. Each node have a maximum of 2 leaves. Left child is always less than its parent, and the right child is always greater than its parent. And let's look at another example here, which also qualifies all the binary search tree's properties, but the one on the left is balanced, and the other one is imbalanced. The main difference between balanced and imbalanced trees is time complexity. For example, in a perfectly balanced tree, if we want to search for an item, it makes our search time logarithmic. But in the worst case scenario, you might need to search through every single node within the tree, which makes time complexity linear. If you are not familiar with the big O notation or the concept of time complexity, we have another video that goes over it, and I'm linking it below, so feel free to check it out. Moving on, you can perform a variety of data operations on BST, but today we're going to talk about these two most basic operations in details, insert and search. So you are ready for more advanced operation. First, let's look at insert operation. When it comes to inserting a new node in BST, we must ensure all BST properties hold true. For example, we want to insert number 20 into the binary tree below. We start at the root node 21, and since 20 is less than the root, we go left. And then we continue this process until we find the empty spot where we can insert our new node. In most coding interviews, you will often be asked to write a code for a generic use case. So now, let's look at a sample code for that. First, we need to define a class called treeNode. So class is like a space where you can create Python objects and their attributes. In our case, the nodes in our BST are objects, and each node has 3 properties: left and right pointers and the value of the node. The init function here is for setting the initial status of these attributes. Now we will create a function that will insert a new node with a given value. If the tree is empty, for example, the root is none, we create a new tree node with the given value and return it. Otherwise, we check if the value is greater or less than the root node's value. If it's greater, we recursively call the insert function on the right child. If it's less, we do the same with the left child. Moving on, let's create a function to search our tree. We will call it search, and it will take 2 parameters: the root of the tree and the value x we are searching for. If the root is none, it means that the tree is empty, and hence X is not in the tree, so we return the original tree. If the null value is equal to X, it means we have found the value we are looking for. Otherwise, if X is greater than the root node, we know it can't be in the left subtree of root, as all values in the left subtree are smaller than the root value. So we recursively search in the right subtree. Vice versa, if X is less than root value, we recursively search in the left subtree. As you can see, both search and insert function are very similar in nature. The key here is to use recursive function until it meets the stopping criteria. For insert is when you find the location where you can insert the value as a leaf node. For search is when you either find the value or you search through the entire tree and cannot find it. And that wraps up our deep dive into the binary search tree. Let's do a quick recap. We hope this video helped you understand what is a binary search tree, what are the 3 key properties, and how to write a generic Python code for search and insert functions. In our video, we also quickly touched on the difference between balanced versus imbalanced tree. There are algorithms like AVL or red-black tree which has self-balanced property that will help our code to reach maximum efficiency. And we will cover these advanced topics in future video.
Before we go, don't forget to like our video and subscribe to our channel. We have a lot of more Python coding topics and tutorials on the way. Stay curious, keep learning, and we will see you in the next one where we will dive deeper into more complex data structures and algorithms. Until then, happy coding!